All right, what's going on, y'all? Sean of MassWat Tutoring here with another video. Today we're going to be talking about scale factors. But before we get into it, make sure you like this video, make sure you subscribe to this uh YouTube channel. And yeah, let's go ahead and get into it. So, scale factors. This is a concept that's very much related to the discussion of ratios and proportions, okay? Let me write those terms here. Ratios and proportions. And so just to recall a ratio, I guess I can just write the definitions down here and then I erase these so I'm not being redundant. A ratio is basically a comparison of one value, one quantity, I'll say in relation to another. But let me say it this way. I'm going to type it, okay? So we'll say um a quantity of one I'll say item in relation to a quantity of another item. Okay. Let's stretch this out here this way. Okay. So for example, if you have a bowl of fruit that has apples and oranges and you have two apples for every one orange, you know, or eight eight red grapes for every five green grapes. That's kind of like the ratio of I mean it's like a quantity of one item in relation to the quantity of another item. Now, if we are talking about proportions, proportion. A proportion is two, I say, or more ratios that are equal to each other. Okay. So, like, for example, what we mean by that is like, if you would say that you have a bowl of fruit that has, let's do our apples and oranges. You have a bowl of fruit that has four apples and one orange. Then you have another bowl of fruit that has 12 apples and three oranges. These are proportional because they are equal to each other. If you simplify this, it really is four apples for every one orange. Okay, you see what I mean? So this is an example of a proportion. All right. Now, scale factors are related to this topic of ratios and especially proportions. Because basically what happens is I'm going to label this as original. You have, for example, like an original shape that has been either increased or decreased in size. And in this case, this has been increased in size. In this case, this original has been decreased in size. Okay. Now, this is what you call your scale. And I guess I better do it one at a time. If this is the original shape, this is your scale. This has been scaled up from the original. Okay. And a scale factor is a factor, a number that you multiply. And I'm gonna how do I do this? I'll say side one, side two, and side three. It's a number that you can multiply any measurement for the original by, and it'll give you the scaled up version of that corresponding side. So with this original shape and the scale shape, these are proportional. So what I mean is the ratio of side one to side one, side two to side two, side three to side three, all of these are equal to each other. That means you can multiply any side of this by a scale factor and get the corresponding side of the scaled shape. So the way that's represented is like this: y equals kx. Okay? So literally y stands for the it's a measurement from the scaled shape. X is going to be from the original. Okay? So you can multiply any side of the original shape by the scale factor to find the scaled version of um that same the scaled shape is what I'm trying to say. Also, with that, if you want to find the scale factor and you don't know that yet, but you know the measurements of the original and the measurements of the original and of the scale, you can solve for that. So k times x, if you want to just find the scale factor k, divide both sides by x. Remember, when you solve for a variable, you want to move everything away by performing the opposite operation because this is being multiplied by that. You want to divide it out. X divided by x goes away to 1. Then k, the scale factor, is equal to y over x. So a scale measurement over the original measurement, it doesn't matter which sides you use as long as it's the corresponding side, 1 to 1, 2 to 2, 3 to 3. Each one of those should give you um like the same scale factor. So let's actually put some numbers in here. So let's say I'm gonna make it real easy just so this will make sense. And let's actually change the color here. So let's say, for example, that this measured 2, 2, and 3. And then this was 4, 4, and 6. You want to ask yourself, what is the scale factor? What is the number that we use to scale this shape from this size to this size? So let's get back to black. So if this is our scale, let's find the scale factor by comparing let's use this bottom side and this bottom side. So the scale factor K is going to be equal to y over x, so the scale measurement over the original measurement. Scale measurement over the original. So 6 over 3, which is equal to 2. Okay. Now, I should be able to do the same thing with any of the other sides. The scale factor would be equal to, we can say this side over this side. So 4 over 2, which is 2. And then you'll get the same thing for these corresponding sides as well. So you see, that means that as a general equation for this relationship between these two shapes right here, y is going to be equal to the scale factor 2 times x. So no matter what original side measurement that you put in here, it's going to give you the corresponding scale measurement. Okay, so this is what you would call your general equation. Okay, where you just put in your scale factor. Now, let's do this here. So we'll make this very easy. So let's say with this rectangle, this is 4, 2, 4, 2, and then this is we'll say I don't want to make it too easy. Let's say um 1, 1/2, still pretty easy. All right. So this is our original. This is our scale. Okay. So we know that if we want to find the scale factor K, that's going to be equal to y over x, where y is a measurement from from the scale shape, and then x is a measurement from the corresponding side of the original shape. So let's just do the top one here. So if the original is 4, that's going to go on the bottom. And then the scale is going to go for the corresponding side is going to go on top. So here's your scale factor. That means that I have to multiply a measurement from the original shape by 1/4 to get a measurement, the corresponding measurement from the scale of the scale shape. Okay. Let's make sure that we get the same thing though. Okay, let's see. Let me make sure that I work these out. Yeah. Okay. So I should be able to do the same thing here. So K, I'm gonna take this side now. Okay. So K is equal to a measurement from the scaled shape, which is going to be right here, 1/2, over a measurement from the original shape, which is 2. Now, if you recall, so you're dividing a fraction by a number. So this is essentially going to be 1/2. So 1/2 divided by 2 is the same thing as 1/2 times 1/2, which ends up being 1/4. Okay, you see? So the scale fact, and you can go all around the rectangle and get the same thing. Therefore, the general equation to that shows the relationship between the original and the scale is y equals 1/4 x. 1/4 is the scale factor. Now, I'll say this and let this video be done. You'll get problems where they want you to confirm whether or not a shape is truly a scale of an original shape, and you might have to go around all the sides or more of the sides to confirm that. So what you want to do is you want to put again k is equal to a measurement from the scale divided by a measurement from the original. Okay, just like I said here. Okay, k equals y over x, where y is a measurement from the scale, x is a measurement from the original. And then that'll help you to know whether or not it's a true scale version or not, if you get the same scale factor for all the corresponding sides. Okay. Let me know if this is helpful. Make sure you like, make sure you share, make sure you subscribe, and have a great day. Hey, thank you for watching this video. If you need math tutoring or you need SAT math help, look in the description to find out how you can sign up today. Also, don't forget to like, share, and subscribe so you stay in touch with Math Swap Tutoring on YouTube. Have a good one.